Okay, we're back talking about polynomial arithmetic, and in this video I wanted to show a little bit of division. So let's start with dividing by a monomial. And let's say we had P1 divided by 2x, just to pick something here, okay? I could rewrite this. It's the same as P1 over 2x. Every fraction bar is really the same thing as a division. And in this way, I can fill in the polynomial and make some quick sense of it. And let me just do that and show you what I'm talking about. So this gives me 2x squared minus 7x minus 15 all over 2x. And something I can do here, there are a couple ways to approach it, but one way, and this is especially nice with division by a monomial, is to simply separate each term in the numerator as being over this monic denominator. Wow, don't get those words mixed up. You'll say something crazy. All right, so what I meant was just the monomial down here. This becomes then 2x squared over 2x minus 7x over 2x minus 15 over 2x. And if you take a second to think about it, these are a bunch of fractions with a common denominator, so couldn't I write it as all these operations being performed to the numerator as over the common denominator? Sure. So indeed, if I could go this way, I should be able to go the other way also. Now I can take the division term by term. The first thing I notice here is that these 2's cancel out, and then for the next part, x squared divided by x, remember your rules of exponents, 2 minus 1 power is 1 power, so this just gives me x to the first power. There's my minus sign for the second term. 7 over 2, that doesn't really reduce, but that's okay. The x's cancel out. X to the 0 power is 1, that's another way to say that. So all I end up with is 7 over 2, and I'm just going to leave that. I could call it 3.5, I could call it 3.5, but I like fractions. And on the next piece, minus the 15 over 2, that doesn't reduce evenly by the same number. There are no powers of x in common, or just on top and bottom, I should say. Just the x on the bottom, so I'm just going to leave it as is, 15 over 2x. And that's it. This is equivalent to the original P1 divided by 2x. Okay, let me show, let's try this one. Let's try P1 divided by P2 and take a look at what that looks like. Again, I'm going to rewrite this as P1 over P2 and go from there. So here's my 2x squared minus 7x minus 15 divided by x minus 5. Now this time I have to be a little bit more careful because I have a binomial in the denominator. I could separate it term by term, but it would be 2x squared over x minus 5, negative 7x over x minus 5, negative 15 over x minus 5. You have to take that whole unit, okay? So I'm not sure that's the best approach. In fact, I know it isn't. I'm cheating for this problem. Let me show how to do this division possibly by factoring first, okay? Not every division works out like this, but I want to take a look at the numerator, 2x squared minus 7x minus 15, and see if it has a factor of x minus 5. Because if it does, then those things will cancel out nicely. So let me pause just to take a look at this and determine whether I can factor it, and if it does factor, does it have a factor of x minus 5? Well, let me multiply these two guys together, the leading coefficient in constant terms, to get negative 30. And if you forgot how to factor, then please review the factoring videos. There are 3 methods that I show. What I'm doing right now is what I call method number 3. Starts out the same as method number 2, but yeah, check out those videos. So now I'm looking at what factors of negative 30 also add up to negative 7, and I can say, oh, negative 10 times 3. If I multiply those, I get negative 30. If I add them, I get negative 7. What do I do with those numbers? To come up with the factors of this, I'm actually going to create a couple fractions. Okay? And the first one, I'm going to start with just an x here, minus 10 and always divided by the leading coefficient, 2. Again, this is method number 3. Take a look at it in my factoring videos. And really, I'm misbehaving because I'm solving an equation and I'm not telling you what equation I'm solving. But this algorithm, this method, this works every time, so feel free. As long as you're careful, there are some caveats. Okay, x minus 10 over 2 becomes x minus 5. And I'm going to pull this 2 up to the front and call this 2x plus 3. And now these are the legitimate factors of that. I can confidently say that 2x squared minus 7x minus 15 is equal to x minus 5 times 2x plus 3. When using method number 3, you always have to factor the greatest common factor first. Double check those factoring videos and be careful. So I'm going to rewrite what I have there on the top then. P1 divided by P2 as the following: x minus 5 times 2x plus 3. There's the factored version of the first polynomial. Not all polynomials factor. The bottom denominator, P2, is x minus 5. And that is just dandy because it turns out that this x minus 5 on the top totally cancels out with this x minus 5 on the bottom. And I'm simply ending up with 2x plus 3. And that's it. You can do these canceling type things when you're multiplying, okay? Only when you have a lot of multiplication involved. I want to take a different look at this P1 divided by P2, and I want to look at it in terms of long division. Suppose we were to write this out using long division instead of this factoring method. So for space, I'm going to go ahead and erase this part right here. You can always rewind, pause, all that other business. How nice, right? All right. Maybe this is the new wave. You can pause your teacher. Rewind, fast forward, put a funny hat on them with Adobe. I don't know. Okay. Let's take another look at this in terms of long division. That would look something like this. Okay. Remember, when you're turning a fraction into a long division, whatever's on top here in the fraction goes inside. Whatever's the denominator is goes on the outside. So I'm asking myself, how many times, or how does x minus 5 go into 2x squared minus 7x minus 15? Now here's how we do it the long division way. We don't worry about this entire x minus 5. We just look at the x. And I ask myself, how many times does just x go into the first term here, 2x squared? And so I can say 2x, right? 2x. I probably shouldn't, maybe I should write it over here. But maybe to keep in mind what I'm looking at, I'll write it above this, so we'll just keep it like that. 2x, then, I'm going to have to multiply by both of these terms. 2x times x gives me 2x squared. 2x times negative 5 gives me negative 10x. And now I need to subtract that whole thing, just like we normally do with long division. This minus means negative 2x here means plus 10x there when I distribute the negative. So 2x minus 2x, that gives me 0. That's what I wanted. Distribute that over here, that's a plus 10x. Negative 7x plus 10x is a positive 3x. Okay. And then I bring down my minus 15. And again, I ask myself, how many times does x go into 3x now? And I'm going to say a positive 3 times. So I'll write a plus 3 up here. Then go back to the multiplying part. 3 times x is 3x. All right. 3 times negative 5 is negative 15. And I'm subtracting these two terms. So 3x minus 3x is 0. This minus makes that a plus, which also adds up to 0. That means there is a 0 remainder. And remember, whenever you're dividing anything, a over b, If we do it the long division way, then we can always say, okay, that's the quotient plus the remainder divided by the divisor. Now in this case, our remainder was 0, so all we're left with is the quotient. Let me just point it out. This guy is called the divisor. Okay, you see the remainder right there, and up here, whatever we have there is the quotient. So for this example, the remainder again came out to 0. So all we're left with is the quotient 2x plus 3. So I can say confidently again, as I did over there, or I erased it, as I did previously, is P1 divided by P2 must come out as the quotient here, 2x plus 3. The remainder was 0. 0 divided by anything is 0. So there is my final result. So more examples to come. Stay tuned, and I'll get those videos up as soon as possible. Thanks for watching.